Now, a different type of system when we have a single pulley. There's a single pulley as you see in the example here, and there's two weights hanging on it on both sides. Those two objects are being connected to one single rope. Each one of these weights is being hanged on one side of that rope. So we have object A and object B, and the rope has no mass. In this case, A has a mass of 25 kilograms, B has a mass of 35 kilograms. Determine the motion of each object once the object is released. What is given here? We have the mass for A and mass for B, and we have the gravitational acceleration of 9.8 meters squared down. Find the acceleration of each object. Now we need to find kind of common sense for the physical system that's being drawn in front of us. We have two objects hanging on the same rope over a pulley, but the mass of object B is bigger than the mass of object A. So in this case, this object B, will pull the system downward by gravitational force, and object A will go upwards. So he will go downward with acceleration for object B, and object A will go with acceleration upwards. So now we know the direction of acceleration for each object by the common sense. We start with finding the total mass of the system equals mass of A plus mass of B. That would be 60 kilograms. Then we find an equivalent system in terms of mass so that we can analyze the motion. So we have two boxes here being summed as one box. Do you have the mass total for that box? And you draw the free body diagram from the center of the box. So there is force of B pulling to the right and force of A pulling to the left. That is the weight of the rope on both sides. Always keep the rope in mind while analyzing so that things will make sense for you. So the force of object A equal gravitational force acting on the mass A, and force of object B equal gravitational force acting on mass B. We apply Newton's second law to find the net force acting on the mass total. F net equals FA plus FB, and we replace FA with minus MA by G plus the MB by G. We rearrange the equation and replace those values. We can find that the net force equals 98.1 Newton. You can see here the F net is pointing to the right because the force of B generated by the bigger mass of B would generate a bigger acceleration. In this case, the force of B will be bigger, so the total motion will be to the right. Now the F net equals M total by the acceleration. We can say acceleration equals the F net over the mass total. F net is known by now, 98.1 newtons over 60 kilograms of the total mass. So the acceleration would be 1.6 meters per second square. So the acceleration of A will be 1.6 meters per second square up. Acceleration of B, 1.6 meters per second square down. So the same acceleration for the whole system, but the direction of acceleration per object is different. Now, another system we would have not only one pulley, we have two pulleys. There's two pulleys here, and there's object B hanging over here, object C hanging over here. So we have 20 kilogram truck tire sitting over here. That's object A, lying on a horizontal frictionless surface. There is no friction. The tire is attached to the two light ropes that pass over light, and frictionless pulleys to hanging pails B and C. So the two light ropes passing over light frictionless pulleys, hanging pails B and C. Pail B has a mass of 8 kilograms, C has a mass of 6 kilograms. Find the magnitude of the acceleration of this system. You don't care about direction, you need to find the magnitude of acceleration. You have MA 20, MB 8 kilograms, MC 6 kilograms, and you have G 9.8 meters per second squared down. Find A as a magnitude regardless of direction. He's making life easier for you. Now what we do, we know that mass of B bigger than mass of C. So the force would be pulling towards the mass of B. In the meantime, we find the total mass, MA plus MB plus MC would be 34 kilograms. You draw the pre-body diagram, you have the total mass, FC pulling to the right, and FB pulling to the left. FB would be the one who's pulling because of a bigger mass. So the direction of the system or of the total mass of the box over here would be to the left. Keep going, we have the total mass. Now we draw the schematic of forces, FB to the left, FA, FC to the right, F net would be to the left. Now the F net equals FB plus FC. FB is in the positive direction, Fc would be in the negative direction. Replace Fb with the mass of B by g minus the mass of C by the gravitational acceleration. Rearrange and compensate the values. We know mb, we know mc, we know g. Plug them in. You will find that the net force 19.6 newtons. Now continuing with the solution, we know that Fnet equals the m total by a. We don't care about direction here. A as a magnitude, so the acceleration would equals the Fnet over the total mass. Fnet is 19.6 that we found earlier, over 34 kilograms for the total mass, and the acceleration magnitude would be 0.58 meters per second squared.